All right. You have to remember all of these terms. We don't really ask you like what is a matrix, but obviously you need to know what the terminology is. Yeah, you need to know these terms in order to apply them. So basically, matrix is an arrangement of numbers recorded in rows and columns. All right, so that is going to be quite important going forward, the difference between a row and a column. I'm not actually sure if they mentioned it here. They didn't. So a row is going across and the column is going down. If you just want to make that, but I think that's just English, right? A row is going across and the column is just going down. But just in case you forget that, that is very important when it comes to matrices. We really need to try and not mix those two up. All right, so the first thing there is matrix, and we are going to work with matrices, so you'll see now what they look like. It's these things here in the brackets. Now, what we do need to know is the next sentence there. The individual numbers are called elements or entries. I usually refer to them as elements, but if they use the word entries in a test or exam, you do know that it's the same thing. Now, guys, if we're looking at these three, we have three examples of matrices under the next heading. All right, here, this one would be the smallest one. This matrix has two rows. Do we see that? 1, 2. And also 2 columns. All right, so it does say later on where we're talking about the dimension or the order or the size of a matrix, but we can also just write it underneath here. If they ask you for the dimensions or the order of this matrix, this would be a 2 by 2. So you always list how many rows, that's the first number, and then how many columns, that's the second number. So this matrix would be a 2 by 2 matrix. 2 rows by 2 columns.
Is it always rows by columns?
Yes, always rows by columns. And it is on the second half of the page. We will highlight that just now. They've written it on the second half of the page. If you're looking at n, how many rows do I have? 1, 2, 3. And how many columns? 1, 2, 3. So 3 by 3. 3 rows by 3 columns. And guys, just by the way, the two numbers are not always going to be the same. All right. It's just in these examples. If we're looking at the next one, at P, how many rows do I have? 1, 2, 3, 4. How many columns? 1, 2, 3, 4. So what are the dimensions of that matrix? Rows by columns, 4 by 4. Okay, that is going to become quite important when we do multiplication later on. Basically what they've just, the leading diagonal, that's actually what this thing is about. The leading or the main diagonal is from top left to bottom right. That would be the leading diagonal. So just the numbers, the elements in that leading diagonal. All right, so in this case, the leading diagonal would be A and D. For the next one, the leading diagonal would be A, E, and I, just those numbers there. I mean, they are letters, but they will be numbers, right? We're going to be working with numbers. And in this case, for P, the leading diagonal is A, F, K, and Q. Those 4. Very nice. So we can highlight that. The leading diagonal, they don't really refer to it as the main diagonal, but they always say leading diagonal. Okay, so those are, yes. Yeah.
M and P period with not the O.
No, I don't know why they don't really like using O. I think maybe because it can be confused with a 0. So yeah. All right, now for the trace. Now the trace of a matrix. So if they're asking you for the trace of a matrix, that is a number. Okay, that is a number. Sorry about that. That you are going to calculate. So the trace is an actual value, and that is when you are adding all the elements in the leading diagonal. All right. So now do we see that we kind of layering terminology? Okay. So the trace is the sum of the elements or the entries in the leading diagonal. So let's just highlight that. But guys, they're not going to give you that definition in a question, right? I can give you any matrix and I can just say, calculate the trace of this matrix. All right, then you need to know, okay, I need to find the leading diagonal, which is from, it's always from the first number. All right, the top left. all the way down to the bottom right. And then you also need to know that to get the trace, you must add them all. Yes.
And yeah,
Yes, they can. Yeah. In which case you'll define it. So that's not difficult, but obviously if you don't know what trace means, then you won't get the trace. Okay.
would you work off the cycle of
A 3 by 2, yeah, so you wouldn't really have one because it would be off. It would be, yeah, we'll get to that. Yeah, the different types of matrices. So don't worry about that for now. All right. Row echelon. Echelon, I'm not sure. Echelon. We're not going to do a listening test. Okay, as long as you can see the word and you know what it means, that's fine. My varsity lecturer, sorry, used to say echelon, but also she was Hungarian, so who knows. So the lower triangular half of the matrix. So guys, what they mean by that is any matrix, any actually square matrix, we'll get to that later, any matrix that has the same number of rows and columns, right? That is at the bottom. Sorry that I'm mixing terminology up. Let's quickly go to the bottom. Let's just get this one down. A square matrix is where you have the same number of rows and columns. Okay, that's what they mean there. Dimension or order or size must be of the form n by n. So same number of rows and same number of columns. All right, so that's what they mean by square matrix. So now we can start comparing. What does a square matrix look like versus what is a non-square matrix? I don't know. They don't really have names. It's not a square matrix. All right, but here we have 2 rows by 2 columns. There we have 1, 2, 3 rows, 1, 2, 3 columns. Here we have again 4 rows and 4 columns. Oh, it's frozen there. Let's just wait for that to start moving again. Where is it now? This one. There we go. Okay, so those are square matrices. So guys, if you have a square matrix and you have a leading diagonal, all right, so here the leading diagonal would be AD. Now, if the bottom half underneath, below the leading diagonal, if all of those numbers are 0, right, then we say that the matrix is written in row in row equal, let's say it. All right. So, like you can see here, it's a bit easy to see if it's not just a 2 by 2, maybe it's 3 by 3. There you can see that you have your leading diagonal. You can have any numbers up here, guys, even some zeros as well. But if the bottom half is all of those numbers are 0, sorry, then it's written in that way. They don't really ask this as a question. It's more that we're going to use this to solve some equations, so we'll get to that later on, but just highlight that name of the formula. No. If all those numbers are 0 underneath below the leading diagonal. Okay, now we get to dimension or order or size. We have discussed that already. So let's just highlight that. And that is always the number of rows multiplied by the number of columns. And guys, that's going to be a question in an exam, right? I can just give you a matrix and I can ask you for the order or the dimension and you write and you get them off. Okay, so it's quite easy. You must just remember, always rows by column. Right, always rows, columns. So here, let's count how many rows do we have? 1, 2. And how many columns? 1, 2, 3, 4. So the dimension or the order there is 2 by 4. Is this a square matrix? Do I have the same number of rows and columns? No, so it's not a square matrix. What about the next one? How many rows do I have here? 1, 2, 3. How many columns? 1, 2. All right, so this is a 3 by 2. Guys, if you write 2 by 3, that's wrong. Okay, you have to always have your number of rows first and then columns. Yep.
So can I ask you for the leading diagonal of a non-square?
I don't, yeah, that's what Josh was also getting to
You
earlier.
could say like for A, it could be AH. They're just been in between them. No, because these are connected.
Yeah,
Yeah.
so my knowledge, it's never come up, but they literally have major and diagonal when it comes to transferring. So I was going to say that it doesn't exist, but it's never even discussed. But I'll see if I can find some information on that. Alright, and then this one here, 4x4, as you can see, we've looked at this one before. 1, 2, 3, 4 rows, and 1, 2, 3, 4 columns. That means dimensions there will be 4 by 4. Are there any questions on any of this terminology that we've looked at now? Okay, we are now going to actually do some examples of where we are adding and subtracting matrices. Very simple, like I promised, we're doing very easy work today. So please, on the next page after this page, can you just write down operations with matrices? Today we're doing addition and subtraction and multiplying the matrix by a number. And on Friday we're just doing multiplying matrices, and that's it. Operations with matrices is what you're writing down, please.
Oh, that's great. No, my foot gets really now.
Okay, we are going to, as our first type of operation, we are going to write adding and subtracting matrices. So that is the first type.
I think we should provide us all with iPads.
One of my kids actually got one now since I started using it. Subtracting matrices, but also the battery dies quite quickly, so it's not. No, I've already had to charge inside. Already, but I've been pushing it to do this. Okay, adding and subtracting matrices. Guys, it really is as simple as you're just going to add and subtract matrices, right? There's nothing funny about it. The only thing is you can only add and subtract matrices that have the same dimensions. Okay, I'll show you why that is just now, but let's just write that down as a little note. So we're just going to jump straight into some examples. There isn't really anything else that we need to write down. So I'm going to do my bracket here. This is going to have 2 rows, this first matrix. So you can just do your spacing like that. So we have 3 and -1 and 0. And then we have -2 and 2 and 4. And that is the end of that first matrix. Now we're going to say plus. -2, 2 at the bottom there, 2 and 1 and 5 and -3. But the reason for, sorry, let me actually just write something underneath this. The reason for why we can only add and subtract them if they have the same dimension is because we're literally going to take this first number plus that first number. And that's going to be the first number in my answer matrix. That makes sense. So we're going to say 3 plus -2 is what? 1. So that's going to be the first number in my answer. All right. And if you don't have the same dimensions, some of your numbers aren't going to have like a number to match up with. So let's just quickly write underneath this. What is the dimension of this first matrix? How many rows do I have? 2 rows and 3 columns. Okay, so let's just write just so that we get into the habit of finding the dimension. Maybe ask for it. Okay, we're just adding it. that matrix has the dimensions of 2 by 3, and the next one as well, right? The next one also has 2 rows and 1, 2, 3 columns, so that one is also 2 by 3. You can obviously see just by looking at them that they have the same dimensions, alright? So you don't have to still write the dimensions down. Now guys, if you are working with 2 matrices with the same dimensions and you're adding or subtracting them, your answer is also going to have the same dimension. Okay, so let's do this. Let's put in our brackets. Like we said, 3 plus negative 2 is the same as 3 minus 2, right? So that is going to be 1. Now you can go in any order that you want to, but I prefer usually to finish up the first row, but it really doesn't matter. Now we're going to take the next value there, the next element rather, negative 1 plus 2 is what? Also 1. Next one, 0 plus 5 is 5. It really is as simple as that, guys. Just match the numbers up and add the subtract.
And our whole exam is this.
Absolutely.
No, but this will definitely be in your exam. All right, negative 2 plus 2 is 0. Next one, 2 plus 1 is 3. Last one, 4 minus 3 is 1. There we go.
Now, since the row example can only be within the square,
Yeah, comes back to that using the diagonal. Any questions on this one, guys? I think it's quite simple, right? Right, let's do another one. This is now going to have 3 rows, so just make your bracket big enough for that. So we have a 7, and then a 2, and then a 0, and a negative 1, 3, negative 1. Now we are subtracting. We have 3, 0, 2, and 1, 3, negative. Sorry guys, before we actually do this one, I just want us also to write the dimensions of this answer here. My apologies. This also is a 2 by 3 matrix, right? 2 rows and then 3 columns. Can we also just add to this little note that we wrote up here where we said we can only add or subtract matrices with the same dimensions? Can we just add a little then arrow and also just say there, then answer will have same dimensions. Yeah.
If you have all zeros in a matrix, you start with 0. Like, if you were to do an equation with matrices, and one of them had all zeros in it, if you do it,
It depends on what you're doing with it. So if you add on the task, not sure, it's not gonna think, but when we get to multiplication, it's gonna be different. We'll be doing that on track. But also with multiplication, you're not just gonna multiply one element by one element. There's a different, it's a different.
with like, inside the answer, if there are only zeros inside the matrix.
No, then you would write, oh, I see what you mean. Then you would still have your matrix with all of the zeros. Yeah. So you would have to write it as a matrix. Okay, guys, let's quickly find the dimensions. Obviously, just by looking at it, we can see that these do have the same dimensions, but again, let's just practice. How many rows do I have? 1, 2, 3. Yes, in both of them. And how many columns? 2. So these are both 3 by 2 matrices. Now, guys, I want you to recognize that a 2 by 3 is different from a 3 by 2. Okay, even though we have the same numbers, the first number always refers to the number of rows, and the second one to the number of columns. Okay. Let's get to this answer here. I'm just going to put my bracket in again. Now we are subtracting. Okay, so now we need to say 7 minus 3. 4. Yes, you agree? 7 minus 3 is 4. Yes, I think so too. Next one. Negative 1 minus 1 is negative 2. 2 minus 0 is 2. 3 minus 3 is 0. 0. Remember? Over there, 0 minus 2 is negative 2. And now just this last one, guys, we're now saying negative 1 minus negative 2 is going to become plus 2, right? So what's negative 1 plus 2? 1. Okay, so that's just one thing that you need to be aware of when you are subtracting. And again, we have a 3 by 2 matrix as our answer. Mhm.
So this how would you want to lay it out?
Just like that.
So if you want with this okay, would you want to be have a space in between? We want to right here.
So if you're writing next to each other, you just have to get confused. So it mustn't look like a 23. So that's why I do always leave a little bit of a gap. Okay, now guys, actually this is something that was on the next page that I didn't copy, so we're just gonna have to quickly add this to the example, but it's fine, it's not that bad. All right, just the last example of this. I'm going to let's do wait, I just want to see how many spaces did I need. Okay, let's do 2. This one's gonna have 2 rows, the first one. So it's 3 and -2, and then we have a -1 and a 2, and we have a 0 and a 4. Minus, but now the next one is actually going to have 3 rows. But now this matrix has, it's almost like an exponent, if you want to see it in that way, of a t. I'm going to write next to it now what that means. Sorry, it is in the terminology, it's just on the second page, I didn't realize that. But by the way that these matrices are written now, can I actually subtract the one from the other? No, okay, they don't have the same dimension. So now that is where this t comes in. Sorry, I'll move back now in case you haven't finished copying this out. This stands for transpose or transposed matrix if you want to write it out in full, but transpose is also fine. Now the transpose or the transposed matrix is where you swap the rows and the columns around. Okay, so swap. Now swap, is that with an A or an R? Well, it must be with an A. Swap rows and columns. So as soon as you see that T, you are going to have to take the matrix that's given and swap its rows and columns around. So what that means is that the rows are going to become the columns. So how many rows do I have here? 1, 2, 3 rows. All right, my first row is 1, -1. That is now going to become my first column. 1, -1. So instead of it being written across, we're going to write it going down. Okay, so it might be a little bit confusing. We're going to do it now together so you can see. And then which side you meant to copy. This one becomes the first row becomes the first column. Second row becomes the second column. Third row becomes the third column. No, I know that is like which number is on top. The first one. Guys, let's just again write down these dimensions because that is problematic in this question. In the first question, we have 2 rows and 3 columns. So this is a 2 by 3. This matrix is a 3 by 2, but now I have to transpose that, which is going to turn it into a 2 by 3. So you do have to have your wits about you guys, especially if you are in the habit of working very fast. It's very easy to get confused. Okay, it seems it's quite simple, but you just need to make sure that you are swapping them correctly. Okay, so the first one is going to stay as it is. We have our 3, -2. Unfortunately, this is just like any other maths question, guys. You can't just, you have to write the whole thing out. Okay, even though I'm not changing anything about the first matrix, I do need to write it again. You can say minus. Now we need to transpose the second one. So guys, like I said, the first row becomes the first column. So what is my first row? What are those elements? 1 and -1. Those numbers now become the elements in my first column. First row becomes first column. Okay, second row is 2, 4. That now becomes second column, 2, 4. Third row, 4, -2 becomes third column, 4, -2. Yes, so look at it in that way as well. You can say first column, 1, 2, 4, becomes first row, 1, 2, 4. Second column, -1, 4, -2 becomes second row, -1, 4, -2. Now they have the same dimensions, right? So now I can actually subtract them. So do that on your own quickly. I'm just going to write the dimensions here at the bottom. These are now both 2×3s. Just do that subtraction on your own for me, please. Yeah, I think that's right. You can check the answer there. Yeah. Yep. So we're just going to add now we multiply a number if we're having a national function. Why have you done vectors and scalars and so no, we're not talking about vectors, but scalars without the x. Doesn't have a dot with that. It's not a yes, okay. So now the next type of operation that we're going to talk about is multiplying a matrix by a scalar, which sounds very complicated, but it literally just means multiplying a matrix by a number. That's all it is. Okay. I'm just going to use the word scalar because I don't want you to see it in the textbook and get it right. It's just a number. Okay, so that is the next thing. Do you guys have any questions on addition and subtraction? Let me just see how much space I have left. Okay, so 2. Oh, got 76, right? Okay, multiplying a matrix by a scalar. I'm just writing here. This is just a number. Me? Yeah, you have just equal number. No, that's just in the source. Something saying. Sorry, that's not the one. You can just chuck it in that box thing. Yeah, I did that. That's not a game out of my life. That's a lot of stuff. Yes, how big is the box? No, it was not very big. Okay, example. Guys, it's very simple. We're just going to do some examples, just 2 of them. So if you have, for example, a 3 and then you have your matrix. So just like multiply all of those elements by 3. And that's it. That is the answer. All right. So I think you are all more than capable of doing that. Multiplying numbers by 3. So you are obviously not going to write the 3 in front of that. I want to say bracket, but it's actually matrix. You're not going to write the 3 in front of the matrix anymore. You obviously going to multiply it in. So 3 times 1 is 3. At the bottom here, 3 times -1 is -3. 3 times -4 is -12. 3 times 6 is 18, right? So not mistaken. 3 times 0 is 0. And for the last one, 3 times 3 is 9. Okay, easy as that. We're just going to do one that is slightly more complicated, but not really, just where we are putting together addition and subtraction and this multiplication by scalar. So if you have something like a 2 and then you have your matrix 5, -2, 2 and 1. And you are then adding 3 times the second matrix. Yeah. Just a combination of it. Yeah, that's the whole question. You can do it on your own, please. So guys, obviously we've all that question where you have an number that you must multiply into a bracket before you add and subtract. Same thing here. Yeah, it's the basic stuff. grade 10, but they're in matrices, it's quite nice series. Worse, more complicated, yes. So worse. I wouldn't use the word worse.
Sure enough.
I don't mind if there is a technique, you know,
Yeah.
So guys, just like in maths, you need to show your work experience. So I would suggest that you show that middle step, you will get marked for it. You will get a mark for each of those matrices and then a mark for the final answer. 1, maybe 2 marks. Yeah, I don't think that's too bad, hey? I'm gonna give you guys some work to do on this. No, we don't do dividing. Exercise. I will put it on the board for you now. Well, actually, I'll post it on Google Classroom over 2 pages. On page, and guys, the numbering system is a dodge. That's literally what it is in the book. Yeah. So I think it's I suppose matrix, and then there's a GT for graph theory. It's a bit strange. So it's not just numbered from 1 to 11. It's like different. But basically, it's page 8, guys, in the book. All right. So don't stress about that too much. And then it also says exercise matrices 1.1. I'm assuming. And then when we get to graph theory later on, it says, let's check. Yeah, for the graph theory, it says exercise GT. Yeah, I suppose. Okay, guys, I'll put the first one on the board for you and I'll post them. Oh, sorry, you're not doing the whole thing. Oh, goodness. Number 1 and 2 only, my apologies. You're very nice. Yes, this is for Friday. Can I get the first one on the board? Okay. Can you guys read that? No. Alright, that is number 1, guys. Then number 2, I'm just giving you a heads up. They have given you different, so the first, you have to solve for x, y, and z. Alright, but they're giving you like a matrix plus another matrix is equal to this, and you must just fill in a couple of the elements from there to make the equation through. So it's different from what we've just done, but I think you guys will be able to manage it. I do just want to point something out. Sure, I wonder, does anyone have this book here? Can you please check on in 2B? Do you have it in front of you? In the answer matrix, it's for -6 and then 6 and 8. Okay, so that must actually be a -6 as well. Okay, thank you. I'll show you guys now. So Simon, both of them must be -6.
Are you sure?
Yeah.
Are you sure? Are you sure
It's fuzzy, guys. It might be blurry. Okay. Sorry. No, oh god. No. He was kidding. He was kidding. He was just trying to get out of the tube. No. Okay, number 2, guys. I'm posting number 2 for you on Google Classroom because there's actually a mistake in the textbook. So there is a number that should be a -6. So I fixed it on my copy. So please, when you are doing this work, do it from Google Classroom.
Where is it? Outside.
I'm in engineering and I think yeah, it's perfect.
I would do 2 minus. If you want to do -2, then you're gonna have to put a class in. We would
I think it's a big thing in computers, yeah. You might still do it.